Now, what is the another molecule, students? CH4. Central atom is carbon. Central atom carbon, group number 4, valency electrons 4. 4 valency electrons here. Around the carbon, 4 hydrogens are available. Each hydrogen having 1 electron. Hydrogen electron overlap with carbon electron. Now, what is the hybridization? S, each pair considered as each orbital. S, P1, P2, P3. So, what is the hybridization here? sp3 hybridization. Total pairs 4, bond pairs 4, lone pairs 0. Any lone pair is there? No lone pair. In this condition, the shape of the molecule is tetrahedral. Tetrahedral arrangement existing like this. Yesterday in video, I gave you shapes of the molecules. Once look at the shapes of the molecules. Here, this bonding in the molecule which is more electronegative element, carbon. So bonding electrons moving carbon side, all the bonding electrons. So each bond cancel to each other. So dipole moment in this case is equal to 0. So methane is dipole moment is equal to 0. So it is a polar molecule or non-polar molecule? Is a non-polar molecule. Before examples, if you are observing BeCl2 dipole moment 0, it is non-polar. Next to CO2 dipole moment equal to 0, it is non-polar. Boron trifluoride dipole moment equal to 0, it is non-polar molecule. Now here ammonia dipole moment not equal to 0, it is polar molecule. So shapes of the molecules are the deciding factors. The molecule is a polar molecule or non-polar molecule. One more example, if you are observing PCl5. Phosphorus is the central atom. Phosphorus, 5th A group element. Valency electrons 5. 1, 2, 3, 4, 5. Around the phosphorus, 5 chlorines are present. 5 chlorines. Each chlorine valency electron of chlorine overlap with phosphorus electron. Now what is the hybridization? S, P1, P2, P3, and after p orbital completion, next orbital is d orbital. So what is the hybridization here? sp3d hybridization. Overall, how many pairs? 5. Bond pairs 5. Lone pair 0. In this condition, the shape of the molecule trigonal bipyramidal. Yesterday's video, I already shown you shapes of the molecule. Once look at that, students, that video. Here the phosphorus, the chlorine, another chlorine. It is look like which arrangement? Trigonal planar arrangement. One chlorine is existing above the plane, another chlorine is existing below the plane. These two are oppositely exist to each other. This is this direction, this is this direction. Because of chlorine is the more electronegative element compared to phosphorus. Cancel to each other. These two bonds are same plane. That dipole moment this direction, this bond this direction. Cancel to each other. So what is the dipole moment here? 0. Dipole moment 0 means it is non-polar. PCl5 is non-polar molecule. One important point, yesterday I told you, in the PCl5 molecule, 2 types of bonds are present. In the trigonal planar arrangement, the bonds are called as equatorial bonds. Equatorial bonds are shorter bonds. Now here, these 2 bonds are axial bonds. Axial bonds are longer bonds. So in the PCl5 molecule, 2 types of bonds are present, students. shorter modes and longer modes. Examination point of view, this data also important, students. If you are observing different molecules, the dipole moment, for suppose BeF2, central atom is beryllium, valence electrons 2 fluorines are present, overlap to each other. What is the BeF2 shape? BeF2 shape is linear. This is this direction, this is this direction, dipole moment equal to 0. So different molecules are there. So based on these observations, based on all these observations, yesterday's videos and today's videos, I am giving you now previous mains question examples, how they are asked the question. Once look at the students previous mains questions. Here the 2024 question. This is also 2024 question. Next, this is 2024 question. This is also 2024 question. Next, 2024 question. This is also 2024 question. If you are observing all these examples, so all the examples questions based on the dipole moment, polar, next non-polar, and highest dipole moment. Next, zero dipole moment, which molecules. Next, non-zero dipole moment. All these questions are 2024 mains examination, student. 24, 24, 24, 24. So look at the each question once. What is the question here now? Number of compounds from the following with zero dipole moment. Zero dipole moment. In the HF, if you are observing the HF, hydrogen and fluorine, fluorine is a more electronegative element, so bonding electrons fluorine side, dipole moment value not equal to 0. Next, H2, hydrogens, both are same electronegative elements, there is no any polarity, so dipole moment value equal to 0. Next, H2S shape is similar to shape of the water because of the same family, sulfur and oxygen. Angular shape, so angular shape means the bonding electron shifting, moving. Here net dipole moment value not equal to 0. H2S not equal to 0. Next, CO2 we discussed just. So CO2 shape is what? Linear, so dipole moment equal to 0. Next, ammonia also discussed. What is the shape of the ammonia? Pyramidal. Dipole moment of ammonia not equal to 0. Next, boron trifluoride. What is the shape of the boron trifluoride? Trigonal planar. Fluorine. Planar molecule. Dipole moment equal to 0. Methane we discussed just. Methane molecule CH4. Tetrahedral arrangement. Dipole moment of methane molecule equal to 0. Next, CHCl3. CHCl3 name is chloroform. Here the carbon, chlorine, here the hydrogen. Here these two bonds, this is this direction, this is this direction. So there is no cancellation, overall cancellation is not existing in this molecule. So net dipole moment value something is existing, that is not equal to 0. Cancellation is not possible. All are different planes, not same plane, not like a boron trifluoride. They are existing in the different plane, that's why dipole moment value not equal to 0. If it is the chlorine, in the place of hydrogen chlorine is present, dipole moment equal to 0 because of surrounding atoms are same, like CH4. So C chloroform dipole moment value not equal to 0. Next, if you are observing SiF4, silicon is the central atom, it is the fourth group element, carbon family, like a carbon connected 4 fluorines, tetrahedral arrangement. All the surrounding atoms are same, tetrahedral shape, here also tetrahedral arrangement, dipole moment equal to 0. H2O, already we discussed H2O. BeF2, H2O discussed, BeF2 we discussed. So among these all molecules, how many molecules have zero dipole moment, students? H2 is the zero dipole moment. CO2 zero dipole moment, boron trifluoride zero dipole moment, CH4 zero dipole moment, and SiF4 zero dipole moment, BeF2 is the zero dipole moment. How many molecules? 1, 2, 3, 4, 5, 6 molecules have zero dipole moment in this question. Number of compounds from the following with zero dipole moment. Remaining molecules are non-zero dipole moment. This is 24. Next question here. This question, students, once you check this, students, in the later video I will explain on this. Check this question 2024. Bye students.